Welcome back with a new tutorial in the course. In this segment, we will be looking at some of the set-related operations that you can use and perform using the MATLAB. The very first basic set-related function that we are going to learn is the intersect function, which, as the name suggests, can be used to compute the set intersection operation. We can use it in a very similar way as we have used some of the other functions. So for instance, if we have a matrix X containing these values and another matrix Y containing these values, so if we apply the intersect function onto these two variables, then the result will be another matrix that will contain the elements that are similar in both the matrices. In this case, it will return the values of 5, 8, and 9. The other variant of this function is that if I suppose I am also interested in the indexes where I can find the intersecting elements. So now when I press enter, it will return two pieces of information to me. One is the intersecting elements, which in this case are 5, 8, and 9, and the other one is the indexes in the first matrix, that is matrix X, where I can locate these intersecting elements. The first value, which is value of 5, so let us also show the matrix X here for the sake of clarity. So this value 5 is located at position number 1. The value 8 is located at position number 3, and the value 9 is at the 4th position in the matrix X. It essentially contains the indexes into the matrix X where I can locate the intersecting elements. The intersection operation can also be carried out on the individual rows of the matrix. If we have a matrix X and another matrix Z, the intersection of these two matrices where I am interested in determining the rows that are column to these two matrices, so we can specify this by this command, where I used an additional argument, which is rows in this case, which essentially specifies to MATLAB that it needs to operate this command on the individual rows rather than individual elements. If we do not specify this, then by default it is going to operate on the individual elements. It will give me the rows that are common, which in this case is row number 1 having this value, and it will also tell me the row numbers, which in this case is only one row, and that row is row number 1. So remember, if we do not include the rows argument, then it is going to take the intersection of all elements, which are 5, 8, and 9, and these are the location of the elements in the matrix X. In conclusion, there are different ways in which the function intersect may be used depending on your particular needs and requirements. Similar to the intersect function, we have a union function, which is very similar in use. So if we have a matrix X again, and we have, let's say, we have another matrix, say matrix Y, and then we apply the union function onto these two matrices, so it will return us the union of X with Y. And these are the values of the results of applying the union operation. We can always apply it to the rows. In this case, it will return to us the unique rows based on the two matrices. Please note that I am using a matrix Z here. These are the rows that are unique based on the matrix X and matrix Z. You may also look at some other options by consulting the help file from here. Another very common set-related operation is the set difference. We can compute this by using the function setDiff. This function will perform the subtraction of elements of one set from another set. So let's subtract all the rows from X, which contains the matrix Z. So for this, we will need to specify the additional argument of rows over here. We need to write rows instead of row, that is, we need to write rows with an added S. This will perform the row-wise subtraction, and in particular it will subtract the matrix Z from all the rows of the matrix X. As a result, we have 2 rows now instead of 3 rows for the matrix X. Similarly, we can also perform the element-wise subtraction operation. For that, we will need to delete the additional argument of rows over here, and then it will perform element-wise subtraction. If we want to perform column-wise subtraction, then we will take the transpose of the matrix X. So this operation can be quite useful if you are implementing some set theoretic operations in your code. Okay, this brings us to the end of this segment. We will be coming back in the new lecture with more math functions. Do come back to cover that, and until then, enjoy MATLAB!